Hi there. In this video, we're going to do the opposite of what we did in the last video. Last time we were given a value. It's not high enough. We were given a value and we were trying to find an area or a probability. Well, in this video, we're going to go in the reverse order. We're going to be given an area or probability and we're going to be trying to find a cutoff value. Okay, so this is called a percentile or cutoff value. So think about, you may have heard this in terms of test scores or birth weights or birth lengths of babies. If someone scored in the 70th percentile on a test, that means they scored higher than 70% of the people. And then they scored lower than 30% of the people. If a baby is the 95th percentile for weight, that means they weigh more than 95% of the newborn babies. Okay, so whenever we see a percentile value, that always corresponds to that percentage is below that cutoff value. Okay, so here it's written out in words here. For any percentage of data, there's a corresponding percentile or cutoff value. That is the value that leaves the given percentage of data below it. So it's always the area to the left. Okay, so we may be given a percentage and need to find the cutoff value or cut score. Okay, so the percentile is, it's actually a value. It's not a percentage. Okay, so let's try this. What we're going to do is go back to the rainfall example, and I'm going to show you how to calculate these using online stat book. So example 2. Let's continue the rainfall example where the mean annual rainfall in Portland is 40 inches with a standard deviation of 8 inches. So we've got our 40, 48, find my numbers again here. 56, 64, 32, 24, 16. And we've already drawn our whole distribution, so this is more of a sketch. But I want to know where the lowest 10%, so somewhere down here is going to be the lowest 10% of rainfall. But I don't know exactly where to draw it yet, so I'm going to go over to online stat book. This is a different page in the online stat book. This one is called areas under the normal distribution. The other one is called that's a prerequisite. This one is called normal distribution.html. And this one is called inverse normal distribution because we're doing the opposite. So for this one, we need to put in our area or probability first. So we're trying to find the lowest 10%. So I'm going to put in 0.10. And then we put in our mean and our standard deviation. So this is 40 and 8. And if it's a percentile, we always want to go to the left. In this case, it says lowest 10%. So that tells me I'm going to go below. And then this one's a little different because it puts the answer right here. Okay, so now I know that below 29.748 is where the lowest 10% of rainfall is. So I'm going to mark that on my graph, about almost 30. 29.748. Switch over to the drawing. So to the left here is 10% of the probability or area. And then this is 29.748 inches. So your cutoff score should always have units because you're finding a value on this scale. Okay, so I want to show you how to write this out as a probability statement also. So one way to write it is say the probability that x is less than or equal to what with a question mark equals 0.10. So before we had this number and we were trying to find this number, the area. Now we know the area and we're trying to find the cutoff value. And the answer is 29, we could round this 29.7 inches. So let's say the 10th percentile of rainfall is 29.748 inches. Or you could round it off. Okay, let's try another one. B is the highest 5% of rainfall. Okay, so now this is going the other way. Label my scale there. The highest 5%. So I'm guessing it's going to be pretty close in here. So let's go to online stat book. Two different ways you could do this, right? So if I do the highest 5%, I'm going to do 0.05 above. And that's 53.159. Oh, it's lower than I thought because I was thinking the 95% rule is 5%, but this is 5% on one side, not 5% on both sides. So here, this is the highest 5%, and it came out to be 53.159 inches. Okay, so let's write that one out. The probability that x is greater than or equal to what equals 0.05. And then we could say, there's a couple ways we could write it out. The highest 5% of annual rainfall is 53.159 inches. So that's the cutoff. It's that or more. That's the cutoff value. I want to show you also how to do this on Geogebra in case you are preferring to use Geogebra. Geogebra, if I go back to the first one, it was less than or equal to. You see how there's two boxes here? This was our answer box before, but you can actually type into that box. So if I type in 0.10, then my answer goes over in this box. That's why it's called inverse, because the input and output are reversed. So then I get 29.748 if I round. This gives us more decimal places. And then for B, if I go to greater than, and I put in 0.05 for the answer, I get 53.1588 or 159. Pretty cool, huh? Also, there's another way. You might be thinking, well, why don't I just put in 95% to the left? So we could also do that because they should give us the same cutoff score. So if I go 0.95 below, you can see we get the same answer. Okay, one more example here, and now we get to use the middle 50% of rainfall. I'm going to show you two ways here. Online stat book is actually very nice for this. We want the very middle 50%. So I know it's not to the standard deviations because that would be 68%. That's why the empirical rule is useful. So I know it's in here somewhere. And I want to know, what are these two cutoff values? Okay, so online stat book is really nice for this because we have this between feature right here, and then I just need to change this to 0.5. And what this one does is it automatically makes this area the middle 50%. We could have 50% shifted over to the left or the right. You can see it's centered right here on 40. And so this gives us the middle 50% or the middle 60% or middle 80%, whatever it is we're looking for. So here we have 34, let me write these down first, 34.604 and 45.396. So those are both in inches. Those are the cutoff scores for the middle 50%. The middle 50% of rainfall is between 36.4, 0.6 604 and 45.396 inches. Okay, now if you use Geogebra for this, there's a little extra thing you have to do because it doesn't automatically put the 50% in the middle. So I want to show you this in case you need it later on for any reason. Let me draw another sketch right here. If our middle 50% is right here, we need to calculate what percentage is on the left and what percentage is on the right. So I need to take 1 minus 0.5, which is 0.5, and divide that by 2 since there's half on each side. You might have done it in your head that this would be 1/4 on each side. But if we might have to do that for the middle 60%, 80%, and so on and so forth. Now, Geogebra is a little bit harder to do this particular problem, so we have to find each one of these separately. So for this one, we would say probability that x is less than or equal to what equals 0.25. And then for this one, we would have to say a probability that x is greater than or equal to what equals 0.25. So you can see we're not actually using the 50% in our calculation, in our technology. So we have to figure out the lower amount and the upper amount first. And that's because if I go over to Geogebra, I go to the middle, excuse me, I can't just put in 0.5 here. Yeah, it doesn't work. This is not an input field, so this Geogebra just doesn't have this feature. So for this reason, another reason, because of the image and because it has this between feature, it's really nice to use the online stat book. Okay, so that is how to find percentiles or cutoff values. So you're putting in an area this time, or a probability, and you're finding a value with units. Okay, thanks for watching. I'll see you in the next video.